Got a Java exam breathing down your neck? Well, you've clicked on the right explainer. In just the next few minutes, we're going to absolutely nail the top 10 concepts you need to know to walk in there and crush it. Let's do this. Yeah, that pre-exam feeling, it's a lot, right? You're looking at this huge pile of notes, and your brain's just buzzing, trying to figure out what's actually important. Trust me, we have all been there. But hey, don't sweat it, that's what this is for. We're going to cut through all the noise and just laser focus on the 10 things that pop up on exams time and time again. By the end of this, you're going to feel so much better.
Okay, let's start at square one. A super quick refresher on what Java even is. You gotta have a solid foundation before you build the rest of the house, right?
So if you remember anything, remember this definition: platform independent and object oriented. Platform independent is the magic part. It means you write your code one single time and it can run pretty much anywhere. A Windows laptop, a MacBook, you name it. It's the whole write once, run anywhere philosophy. And these features, this is exactly why Java is so huge. It's designed to be simple to learn, it's built around these things called objects, which keeps everything neat and tidy, it's secure, and it's robust, which means it's really good at not crashing. It's a killer combination. All right, here's a classic exam question. I guarantee you'll see this. JDK, JRE, and JVM. The textbook definitions are right here. JDK is the whole kit for developing. JRE is just for running the code. And the JVM is the engine that does the actual work. Now, let's make that way less boring. Just forget the tech speak for a minute. Think about baking a cake. The JDK, that's your entire baking set. The flour, the mixer, the bowls, everything you need to create the cake. The JRE is just the oven you need to bake it. And the JVM, well, that's kind of like the heating element inside the oven, the part that actually does the cooking. Simple. Okay, moving on to the very heart and soul of Java, object-oriented programming, or OOP. These are the big ideas that make Java so powerful. And here they are, the 6 pillars. You gotta know these. A class is just the blueprint. An object is the actual thing you build from that blueprint. Inheritance is like, well, real inheritance. A child class gets properties from a parent class. Polymorphism is a fancy word that just means one thing can take many forms, so one function can act differently depending on the situation. Encapsulation is like putting your data in a protective capsule to keep it safe. And abstraction is all about hiding the messy details and only showing what the user needs to see. All right, we've covered the big picture. Now let's get down to the actual bricks and mortar you'll use to write your programs.
Data types just tell the computer what kind of info you're storing. It's super intuitive. If you're storing someone's age, that's a whole number, so you use int. Storing the price of a coffee, that has a decimal, so you use float. Just a single letter, like M or F, that's a char. And for a simple yes or no question, like did the student pass, you use a Boolean for true or false.
Now, what in the world is a constructor? It sounds complicated, but it's not. It's just a special function, and here's the key part. It runs all by itself, automatically, the second you create a new object. You don't call it, it just happens. Take a look at this code. It makes it so clear. We've got a car class, and inside, a constructor that prints car ready. Now look at the bottom line. The moment we create a new car object with new car on it, that constructor fires off and car ready instantly gets printed. See? Automatic. Okay, let's dive into 2 topics that trip up so many students. If you can get these 2 straight in your head, you're going to be way ahead of the game. First up, double equals versus dot equals. This is a biggie. Double equals asks, are these 2 variables pointing to the exact same spot in the computer's memory? It's very literal. But dot equals asks a different question. It asks, is the stuff inside these 2 objects the same? It's a huge difference. One checks the container, the other checks the contents.
Next up, overloading versus overriding. They sound similar, which is tricky. Overloading is when you have methods with the same name, but they take different inputs. Think of an add function for whole numbers and another add function for decimal numbers. Overriding is completely different. That's when a child class says, you know that draw method my parent has? Yeah, I'm going to create my own version of it that's better for me.
So, writing code that works is cool. But you know what's even cooler? Writing code that doesn't completely fall apart the second something unexpected happens.
And that is exactly what exception handling is for. It's your program's safety net. If your code tries to do something impossible, like divide by 0, it throws an exception.
Instead of crashing, your code can catch that exception and deal with it without shutting everything down.
Now, Java isn't just about logic running in the background. You can use it to build stuff that people actually see and interact with. You might hear about applets, which were for web browsers, but the one that's more likely to come up is Swing. Swing is a toolkit for building desktop applications with buttons, menus, text boxes, a graphical user interface. So where does all this awesome pre-built functionality come from? Packages. The toolbox analogy is perfect. Packages are just organized folders full of pre-written code that you can import into your project. Why reinvent the wheel, right? You can just grab the tool you need from the toolbox.
All right, we have covered the key concepts. Now, for maybe the most important part of this whole thing, how do you actually structure your answers on the test to get every single point possible? This is the ultimate trick.
Here it is, the secret sauce, a 4-step formula for a perfect answer. 1. Start with a simple, clear definition. 2. Give a real-life example that shows you actually understand it. 3. If you can, add a little bit of code or a quick diagram. And 4. Finish strong with a confident conclusion. If you follow this, you make it almost impossible for the examiner not to give you full marks.
And there you have it, the top 10 concepts plus the formula for a perfect answer. You're ready. Which of course leaves one last question for you all. What if I made a full, solved guess paper? Long answers, short answers, tricks to remember everything, the whole shebang. Should I do it? Let me know. Now go and ace that exam.